This is the Amp Hour Podcast, recorded July 23rd, 2012. Episode 105, with guest Chris Anderson, Deambulatory, Daedal, Drones.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
I'm Chris Anderson from DIY Drones, Wired, Longtail, and a bunch of other things.
So many things.
A bunch of other things. Well, thanks for joining us, Chris. This is going to be confusing. We've got two Chris's, so we'll do our best here.
That's the most confusing thing we've got tonight. We'll do all right.
Yeah, I think so.
All right. Night? No, it's daytime here. It's midday here in Sydney,
Aussies,
Australia.
yeah.
Oh, I'm sorry.
Yeah.
Anyway, thanks for joining us, Chris. This is going to be awesome. So you are editor of Wired magazine.
Mm-hmm.
You are co-founder of Do It Yourself Drones.
Founder of Do-It-Yourself Drones, co-founder of 3D Robotics, which is the electronics manufacturing arm, the commercial arm of DIY Drones. We make autopilots and aerial robotics hardware. Mm-hmm. I write, got a couple books, Longtail and Free are the two, but there's one coming out in October called Makers, which is all about the stuff we'll probably be talking about tonight.
Absolutely.
I founded a Geek Dad.
That's right.
Which is all about raising children who are excited about science and technology. So I've got 5 kids. I need to say I've completely failed at raising any children who are excited about science and technology. But
oh no!
Yeah.
So is this like a blog? What is this? I haven't heard of this.
Geek Dad? Geek Dad. It started as a group blog. It's now one of the official Wired sites. There's a Geek Mom as well. I hasten to add. Yeah. It's now a series of best-selling books. There's some products in the offing. It's a little mini parenting empire.
All right.
Oh, I'm going to have to get into this because I've got a 14-month-old now. So
yeah, well, the whole point was that there's lots of things that are fun for kids and boring for grown-ups, or fun for grown-ups and boring for kids. But to find projects that are really kind of cool and geeky that are fun for both was a challenge. So the site is designed to share best ideas on that.
What seemed to be the most popular things that actually hit it off with parents and kids in terms of projects?
Well, you can't go wrong with Comic-Con kind of stuff, Star Wars and,
right.
What order should you watch the films and how do you bring the kids
Oh, no.
Lego's always a good start.
Yeah.
Sort of basic electronics, all science experiments, especially backyard science, rocketry, kites, things like that.
Yeah. Seems to dovetail nicely with a lot of the make stuff as well. I mean, I don't think it's not associated, right? But it seems like it's very well aligned with a lot of the same kind of projects and stuff.
We're all good friends, and we all kind of mix in the same circles.
That's awesome.
We've had quite a few episodes where we've talked about women in engineering and girls in engineering and getting more involved. How have you found like you said, you've got Geek Mum, right? Is that an important thing to get girls involved? Is it harder?
Well, no. So I want to be super clear about one thing. Geek Dad doesn't mean geek father son. It just means
right. Of course,
geek child. So
of course.
So we're all about our daughters. As a matter of fact, my daughters are actually more into science and technology than my sons, largely because we have a 3D printer, and they love using a 3D printer to make dollhouse furniture.
Awesome.
Oh, there you go.
Yeah. So
interesting.
So the Geek Mom thing is just for geeky mothers who also want to infuse their children with science and technology, and it sometimes a mother's approach is different from a father's.
Got it. Speaking of 3D printers, I've just got the new MakerBot replicator, and it just broke on me. Not through any fault of my own. I'm just curious, where do you see the 3D printing industry? I know it's in its infancy. Where do you see it heading? Do you have any input on that?
Yeah, it's going to be absolutely huge.
Huge.
So I've had like every 3D printer ever. I mean, I'm still using a Thingomatic, which is the version ahead of yours, and I've broken my share of 3D printers as well. They're still a little fiddly. I think we're kind of in the dot matrix phase of the whole thing.
Right, that's an apt description, I think.
And we need to get to the inkjet phase, and that means plug and play and reliable, but also multicolor and fast and simple and better desktop software. I think there's two things that are going to happen. The first is by the end of the year, you're going to see a crop of really kind of commercial quality ones that aren't sort of laser cut plywood and fiddly Python scripts in the setup process and all that. So you're really going to see it starting to feel like something you might actually just buy in a box and use, and that I think is going to make the kind of user experience easier. And then from a technology perspective, right now we're dealing with extrusion, ABS plastic that's melted and extruded. The next level of sophistication is going to be lasers tracing in a resin of liquid resin. The thing about ABS extrusion is that it limits the speed at which you can produce. I mean, the first thing people realize when they get their 3D printer tuned in is that it's slow. It's crazy slow, and there's really no good way to speed it up because it's based on the thermal properties of the plastic. You sort of need the plastic to harden just enough in each layer so the next layer comes on cleanly without smushing.
So there's a physical limit there.
There's a physical limit there. Whereas with the laser curing of the resin, you don't have the same physical. There are some physical limits, but they're nowhere nearly as constraining.
Did you see the Kickstarter project for that?
Yeah, I did see the Kickstarter project for that. I have not tried that out myself, and to be honest, I after having been kind of alpha and beta testers on all the 3D printers to date, I think I'm going to kind of let this phase, like the first phase, pass and be a late adopter on that one. We don't have.
Where's your faith? Come on.
I know. I'm alpha and beta testing too many things as it is. So this is one where I'm happy to let others take the heat. But also, I'm really happy with my MakerBot, and we don't have serious production requirements. So if it takes 2 hours to do a big print, so be it.
Of course. Where do you see that laser technology? Is it actually mature enough at the moment to get a usable product or a sort of a dot matrix level usable product for the door? Or is it still got some ways to go in terms of material science and things like that?
Well, the professional quality ones are fantastic. I mean, you can buy one for $50,000 or $60,000. That's amazing. So the technology has actually been around since the 70s. But bringing it down to the sub $1,000 level is still a challenge. Among other things, the resin, the consumables are quite expensive. So there's a few things that need to be done, but I think we're talking a couple years at most, no more than that.
And that's definitely the path you think is laser next instead of the powder plastic or anything else like that. I mean, I see a lot of those.
Well, powder plastic typically uses laser as well. It's just a different substrate.
Oh, that's true. Like sintering, yeah.
Exactly. I'm not expert enough to know which of it's going to be. My sense is that the consumables are a little less messy with the liquid resin than they are with the powder.
Well, the powder one of the powder ones is actually it actually is like an inkjet where it actually deposits the organic. It's like an evaporative basically. So you kind of like put liquid on top of the powder and it creates this like sludge, and then you kind of bake it, and that's the.
There's tons of competing technologies. There's also things that actually cut out really thin films of plastic.
Oh yeah,
and so there's a bunch of them. I'm right now I think ABS extrusion is going to mature to the next level, and that's usually about usability and sort of reliability and just ease of setup. And I expect that to sort of carry us through for the next year or two. And at that point, I'd expect the laser ones to be at a consumer price point.
I have a question, just a general question though. Where do you find time for all this stuff? I mean,
I get this question all the time,
really?
Especially from my wife.
Yeah. Do you sleep? Is it a sleep thing, or?
I sleep a normal amount. I'm very good at starting stuff, and then I tend to kind of delegate. I run actually more than the magazine. I run the Wired, the overall brand, which includes the website and the iPad app and events and all that. So that's a pretty big operation, and that's obviously my day job, and that takes me all day. day.
Yeah.
Then the biggest thing that takes my time, Geek Dad has been handed off to another team, so I'm an emeritus, to use the phrase there. My robotic stuff, the drones and the UAVs, is a huge time suck, and I mean that's been just sort of consuming every other spare minute. But I'm getting, I've now sort of delegated most of the stuff, including the dev teams. The software dev teams are now in the hands of professionals, and I by and large reduce this to a couple hours a day. The books, when I'm working on a book, which I have been for the last couple of years, those suck up my weekends, and so I spend way too much time in Starbucks, with headphones on. And then there's the small matter of the 5 kids and the speaking gigs and all that. And I think I'm just sort of I'm kind of happy when I've got too many things going on, or maybe I'm just happy when I'm stressed and overwhelmed. And it just seems like we live in exciting times, and I don't want to let anything any opportunity drop.
Yeah, you're right. You're in the right crowd right now. Me and Dave were talking about that before the show. Actually, both of us are.
Too many irons in the fire, And one of my questions is, we talked about this the other week. The pit of despair is what Nathan Seidel, who's the Spark Fund founder of Spark Fund, he calls it the pit. Yeah, okay, he calls it the pit of despair. I'm not sure if you've heard him.
Yeah, I saw his post.
Oh, okay, yeah, where something like do-it-yourself drones, for example, you got caught where this wasn't supposed to be successful, and now it's sucking all of my time, and and there's that intermediate zone where it's just successful enough where it's sucking all your time and you can't hand it off, and when it was just taking a little amount of your time, or it goes to the other end, like say the Wired stuff, Geek Dad, where you can hand it off to somebody else and just sort of oversee it from atop.
So I think I have 3.
How do you deal with that?
I have 3 pits of despair. The first one, there's probably more than 3. I've only hit 3
levels
so far.
of hell at this point, right?
Yeah. The first one is definitely the moment where a hobby becomes not fun anymore.
Ooh,
so
yeah.
you got into it because it was fun, and then you kind of started to industrialize it and take it up. And I mean, let me give you an example. Let's say that you write some code and you're pretty happy with it, and you post it and you open source it, and then people start using it, and that's awesome. You feel great about that, and then they want technical support, and there's bugs. They want better documentation, and suddenly this little sort of gift to the world becomes this massive responsibility, this kind of albatross around your neck, and what started as a kind of woohoo, I'm coding, turns into oh my god, I'm doing tech support.
Yeah.
So that's the first one. That's sort of not fun anymore.
That reminds me of, we talked to Bunny Huang. He said he had people calling him at 2 a.m. for sales support. And he was like, this is my personal line, but I'll be happy to figure this out in the morning. Like that kind of thing, right?
Yeah. So we've got all that. But I mean, once you really scale up, it's just crazy. I mean, you wake up in the morning and there's literally 200 emails. And they're all unhappy, right? I mean, these are people who are getting stuff for free, and they're all incredibly entitled about it.
Right.
It's like I can't believe your documentation sucks so bad. And I was like, I just got it for free. I mean, anyway, so there's that. The second pit of despair is when things are working really well, and then you scale it up, and you realize that the edge cases just kill you, right? So it worked on one configuration. Now people are bringing in other configurations that you've never seen before, and your code didn't anticipate, or maybe it turns out your 1% failure rate on your boards, multiplied times 10,000 is a really big number, and it's not a really big number; it's a very predictable number, but nevertheless, it's a daunting number.
Yeah,
and then suddenly you realize that all you hear is complaints, and that's the kind of oh my god, maybe I don't have a robust platform here. Maybe there's something fundamentally non-scalable about the project or the code or my algorithms or something like that.
It just sounds so disheartening too. It just sounds...
that sucks. I mean, that's really when something that looked easy turns out to be harder than you thought, or more, or the problems are more subtle, or the algorithm that worked in a kind of a narrow case doesn't work in a broader case, and that's the sort of oh my god, is this actually going to work? I mean, is this actually did I choose the right approach? Is this really gonna get me where I need to be? And there's a crisis there where you really have to kind of ask, you and your team ask some tough questions like, have we made the right choices? Are we on the right path? Can we fix this? And there's these moments where everything you do makes it worse. and and your fixes create 2 bugs, and and it's really dispiriting, and that's a moment where it's all about team building and leadership and communications, and that's where a robust open source system kind of pulls together and just powers through it, because that's horrible, and if you've got something big and gnarly, if you've taken on a big gnarly problem, you're inevitably going to hit that moment where it's gnarlier than you thought. And then the third pit of despair is once you've got it working and it's successful, and you're building a business, then you deal with popularity. It's like you can't meet demand. You've got supply chain problems. You've got inventory problems. And it's like and now everyone thinks you're incompetent because you can't run a proper business.
Right, because a 12-week lead time because of a Japanese tsunami or something. Right? Exactly.
Or the Chinese went on holiday and who knew? And
February. Oh God, Chinese New Year. Run for your life.
Exactly. So the sort of pitfalls of success and volume, are real. And then you spend all your life dealing with supply chain issues. And QA and yield and multiply and 30 trying to negotiate 60-day net and you flow and anyway, we've at this point discouraged everybody.
No, we talk about this stuff all the time on here. Honestly, supply chain is a shockingly huge part of electronics, and I think a lot of our listening audience understands that. So we feel your pain. We really do.
Yeah. So those are the 3 I've run into so far.
Oh, there could be more.
What's all this talk about team? Team. Geez, I'm a one-man band,
Dave the Lone Wolf.
The luxury of having a team.
No, I'm a huge believer of teams. I mean, I'm a terrible, completer. I'm a good starter. Yeah. Fundamentally, I think open source is all about the social factors. Pulling together a team, creating what Tim O'Reilly calls the architecture of participation. Just finding. I mean, it's really interesting. We have about 100 developers now in DIY drones and working on Ardu Pilot is our hardware, and Ardu Plane, and Ardu Copter, and Ardu Rover are the software sets. And it's interesting. We started off real loosey-goosey, saying, "Hey, everyone play. It's emergent properties and all this kind of stuff." And now we have relatively traditional-looking command and control architecture. We have roles and responsibilities and team leads, and people get kind of interviewed before they're added to the team. And of course, we have proper version control and code reviews and all this kind of stuff. And it kind of looks like GE. It's like it's organized around normal kind of almost corporate structures, except for people are motivated by basically non-monetary reasons. They're volunteers, which means you have to. The funny thing about volunteers is that you have to be even more careful and attentive to managing them, because if they're not happy, they'll leave.
It's like having that what Dave affectionately calls FU money, but without the money aspect.
Exactly.
Right?
It's in a funny way, you can mismanage employees, but you can't mismanage volunteers.
Yeah.
Wow. That's impressive.
And you found that was essential to run it like that, to get the Ardu Pilot where it is at the moment? Would you say it was essential, or was it just a...
It's a really complex project. This is the most complex. It's based on the Arduino platform, and it's the most complex software that's ever been written for Arduino. We found bugs in the compiler just due to the file size that no one has encountered before. So at this level of complexity, I think we really do need pretty sophisticated management structure. I'm not to say we're perfect by any means. We've got a long way to go. But people people you may have heard of, like Andrew Tridgell from the Samba project, have been really instructive in kind of coaching us on best practice in open source software, which we and our software. The truth is, our hardware team is really much tighter and so rather smaller, and many of them are employees, so that's easier to manage. And the software just kind of builds on traditional open source software projects. So we're structured around things like Ubuntu, or so we had John O'Bacon from the Ubuntu project, who wrote a fantastic book called The Art of Community. He coached us on some of our community management practices, and again, Andrew Tridgell coached us on some of the experience from the Samba project. So we feel we've got kind of great open source experts who are kind of coaching us on being better managers and coordinators.
Could you tell us a little bit more about the hardware versus software? I mean, how much of it is hardware these days and how much of it is software?
Yeah, it's really interesting. So we're part of the open source hardware movement, which is to say that we release the design files, the CatSoft Eagle files for all of our boards. It's hardware is as a number of people pointed out before, has about 7 layers. Unlike software, which is really a single layer, it's just ASCII text, which we can share on a version control system. Hardware starts with schematics and board designs and bill of materials and instructions and documentation and sometimes CAD images as well. And each one of these layers requires a different form of communications and collaboration. So like version control systems, it's very hard for them to show you a diff on a printed circuit board file. It's very easy to see that in code, very hard to see on a board design. And there's questions like, what are the right licenses for each one of these? What's the sort of preferred file format? So again, with software, it's super easy. It's ASCII. Everybody can read it. What's the preferred file format for printed circuit boards? We use something called CatSoft's Eagle, which is okay. We use it because it's largely free for non-commercial use. But some people don't like giving away their Eagle files because it's so easy to clone. And when we release a product, it now takes less than 7 days for the Chinese to clone us. And basically put a clone of our product into the marketplace.
And they have been actively doing that, haven't they? I know they started like a year or two back, and they
So places like Good Luck Buys basically have our stuff within 7 days of us releasing it. And so part of me says that sucks. We just put like $10,000 and 6 months worth of work into designing that, and they just took our product and they just took our design, which we gave to the world, and they're selling against us, at a lower price, within at the same time.
Yep.
And so that feels bad. What feels good is what's supposed to happen, which is when people take our designs and they approve upon them, or they do derivative designs that add features and functions that we hadn't thought of. So our partners, and we do have lots of partners out there, do that, and they'll do 2 things. They'll either say, look, actually, here's a version of your board that we think actually works better. It's a more graceful design or whatever, and we're like, oh, that's a great idea. Well, we'll thank you because it's an open source design. They put their design back in the public domain, and then we can use theirs. So for someone's, for example, improved on one of our GPS modules by adding a battery, and we're like, that's a great idea. Yeah, we should have done that. Thanks. We'll do that. Yeah. And then sometimes they can do, and sometimes they'll do derivative designs for specialty applications that we hadn't thought of as well. So basically, we just sort of accept the fact that the cloners are going to clone, because we believe that at the end of the day, putting things out there as open source are going to benefit us more than it hurts us. And we have a community as well. You can buy from Good Luck Buy, and good luck to you. Maybe it'll work, maybe it won't, but don't come to our community complaining if it doesn't work because you didn't support them.
Right.
And so we believe that at the end of the day, community wins, and we want to do the right thing for our community.
I agree. What kind of price differences are you seeing? I mean, is it shockingly different?
It's not that much. I mean, again, we're real. We price as low as we can. So we have a really transparent pricing model. It's 2.6 times the bill of materials. That number is based on 2 40% margins, one for us, the wholesaler, and one for another 40% margin for the retailers. And what's nice about that is that we don't charge for intellectual property. This is just the bill of material. It's just the parts and manufacturing cost. So when you charge 2.6 times the BOM, it's really you can't really underprice us by much and still make money. So the Chinese will underprice us by maybe like one of those 40% margins, but so they'll be sort of 40% less than us, but they won't be much more than that. And at that point, we feel like if 40% for 40% price difference makes that much difference to you, and it's not actually if a 40% discount means that much to you, and it's often less than 40%, by the way. Then and you're willing to take the chance, then you're then so be it. You're probably not our perfect customer anyway.
Right, and they're probably taking on the chin too, seeing the less margin. I mean. Maybe not as much, but
also they don't have transparency into the development process. So we release new boards all the time, and if they just made 10,000 of the board that we've just obsoleted with our new version, whoops, had you been part of the dev team and played nice, you would have known that.
Right. So is that a built-in software kind of feature, or not a software feature, but almost a security feature of software being up to date with hardware and just kind of being current with the community? I mean,
again, the software is open source, so we don't we support actually old hardware as long as we can, so at least a year and often 2 years. So it's not like our software will like stop working on our old hardware, but the community will always want the latest greatest stuff. By the way, I want to quickly add something. When I say the Chinese, I'm not referring to all the Chinese. Some of our best contributors are Chinese as well. I want to tell you a little story about there was one of the guy who had started a company who was selling derivatives of our board, was actually being he wasn't just selling via the Chinese eBay versions. He was selling on his own site, and there was a sense they were doing some proper support, and they were part of our they were translating our manual into Chinese. And I thought that was really cool, and I got in touch with them and I say, hey, I'm delighted you're translating our manual to Chinese. If you're going to do it, why don't you do it on our wiki? So that we use the Google Code Wiki, and there's a way that you can actually switch between languages. And I said, it'd be awesome to do it on our wiki so that you can share our images, and so when we update them, yours will be automatically updated. And he's the guy's name. He went by the screen name Hazy, Hazy, and he said, "Cool, okay." So I gave him a login to the wiki. Now in those days we were using a Subversion version control system on Google Code, and I'd set it up wrong so that if I gave you a login to the wiki, you also had login to the code repository. And so first he ported the manual to Chinese, and by the way, he's still up. He updates like almost every day. He's amazing.
Wow,
he translated the manual to Chinese, and then he started translating some of the software interface into Chinese. And I was like, okay, cool. Then he started fixing bugs. And today he's like one of our best contributors. And because we didn't treat him like a pirate, we treated him like a open source community participant, and we sort of invited him in. He's become a great contributor. There's lots of teams in China who are like that. So I know people kind of tend to use a broad brush and refer to China,
right.
But there are, just like in every other country, there are people who are doing great innovative work, and there are people who are just ripping people off. And I just want people to know that there's a lot of the former as well in China.
Right, and there's no reason there wouldn't be a cloner straight in California, right next to you guys as well, right?
Yeah, exactly.
Yeah,
absolutely.
That's a good distinction to make.
If they could get away with it, if they could make a buck from it, they would.
Yeah, exactly.
Yeah. I like to think, though, that there's some unwritten rules in the open source hardware community, and one of them is that you do not rip somebody off just blanket without adding any value in some way back to the project, back to the community, even though you're legally allowed to do it. Because it's open source hardware, they're legally allowed to take your Gerbers and print them, as long as they don't use your trademark name, of course.
They use a trademark name with no problem.
Oh, well, that's it. Yeah, that's legally wrong. But if they physically remove that, then they're legally allowed to do it. But that doesn't mean you should do it.
Exactly.
I think that's overstepped the mark of what the community expects, and you have to give back in some way. You have to make a derivative, make it useful. Not just plain rip off, even though you're legally allowed.
Completely agree. It is, however, an unwritten rule. It is the culture and the philosophy and the spirit of the thing, but it's not legally enforceable.
That's right.
Chris, could you tell us a little bit more about your actual manufacturing operation, since we kind of started to touch on that? I mean, I've seen a couple things about your PCB assembly hardware and everything there. Could you just tell us about overview of what you guys do there?
Sure. I actually don't run it day in day out, and I'm not actually there. We have two factories now, one in San Diego and one in Tijuana. I live in San Francisco, or in Berkeley, actually, outside of San Francisco. We started in San Diego, and that is basically a standard pick and place line with the Mancorp, Mancorp pick and place reflow oven, solder paste printer and all that. So it's a relatively state of the art assembly line. The one in Tijuana is a clone actually of that line, with the addition of specialty devices for through hole soldering. Interestingly enough, we you would have thought because it's in Mexico where labor is lower, we would have used people for that, and we did start that way. But we find that the reliability of mechanized through-hole soldering is such that the automation really pays off. So there's basically two pick-and-place lines. Then we also have two CNC lines that do quadcopter and hexacopter frames, and those run all 24/7 as well. That's pretty much it. We have the R&D and the prototyping side is all in San Diego, so we have the usual range of 3D printers and such to prototype hardware that for our pipeline of new products.
At what point did you go, right, we're going to actually run our own pick-and-place machine and our own CNC machines for mechanical, as opposed to just subcontracting out that stuff to people who already know how to do it and do it properly?
Yeah, well, a lot of this, the credit goes to my co-founder, Jordi Munoz. But basically it started like this. We started a community, and it was like, it's like, hey, we're going to do autopilots, and we put out some designs out there, and it's like, hey, here's some links to batch PCBs, so you can have these PCBs made for you, and then here's the link to the DigiKey products, so you can just order the bits, and here's some instructions on how to solder them together. And that's almost nobody who can handle that. And there was like, could you possibly make them for us? Because that sounds really, really hard.
Yeah.
And we're like, okay. And so we batched up a lot of boards, and I bought stacks of components, and Jordi and I said, well, we'll just make them ourselves, and laid them out on the kitchen table, and then basically went blind. And that was horrible. Hand soldering that stuff. So that took us a couple hundred boards, and we're like, we're not doing that anymore. Then we send them out to a component manufacturer, to a production house,
board assembly,
a board assembly house, and so we used advanced circuits, and they were great. But the problem is that to get any kind of economies of scale, we'd have to order big volumes. So we'd order 1,000, which was a big volume for us back in those days. We'd order 1,000, and then you sit there with your heart in your throat, hoping that nothing is wrong.
Will they sell
with them, or you haven't made a mistake?
Are they broken? Yeah.
Yeah, and then it comes in. Good news! They work fantastic, and then you realize you can't change the design until you've sold all 1,000 of them. So you have incredible inflexibility, and at that point we realized that the only way we were going to get both, we're going to be able to innovate and run kind of an efficient economic operation was to have our own pick and place line, because that allows us to make small batches. So we basically do a kind of on demand production. So we'll make 100 in a day, but we don't end up with a huge inventory of products that of anything, because that would discourage us from innovating and improving on the product. And as a result, so we're constantly changing the product by bringing in new components or things that we were able to source more cheaply, or fixing small bugs, etc. So we'll have in the space of a year we'll have maybe 30 different versions of a board. No one will notice this, but each one is designed to be easier, more reliable, easier to make, or more reliable, or cheaper to make, and all that's enabled by the fact that we have the flexibility of our own production operation.
But how do you trade off? Like you said, might have 30 different versions of the board. How do you trade off the keeping track of that, the documentation, and having people go, oh, my one's slightly different. What the hell's going on here? And all support.
At
what point do you trade off
that.
where it's better to go just stick with the one version for a long time and is trying to milk as much out of it as possible?
Most of these versions, no one would notice. I mean, it's a component here or there, and it doesn't require documentation. When we do change something that people would notice, we do update the documentation. We try not to have too many versions that do that. And sometimes they're just the yield is higher, which is to say, it's only a difference that we would notice in the production, which is that more of them pass QA.
Oh, okay.
And
so solder paste differences and drop-ins and stuff like that.
Exactly. Okay. So we're constantly kind of doing production and process innovation.
Yeah.
But we're still at the stage at the kind of the high high growth or fast innovation period of our industry. So we largely expect to rev every board every 6 months, and just to keep up with the industry. And some people it's definitely too fast for some people. They're like, would you please stop releasing new versions? Because because A is making me feel bad about the product I just bought, and B, everyone requires a new learning process or new configuration, etc.
Right.
And we do hear people on that. By the same token, if we did stop innovating, then people would pass us, and that's not what we want either.
That happened to me. I bought an RG-copter. I'm developing a quadcopter that actually goes through a canyon and actually it'll autonomous do the whole thing, and completely autonomously. And I just bought the RG Pilot and the RG Mega or whatever it was. And then, like the next month, here's this brand spanking new 2.0 version or something, and I went, "Oh."
Well, the good news. I'm sorry about that. The good news, however, is that the 1.01 will fly just as well and is supported entirely by the code. So I know it feels kind of off, but we
at first, yeah.
But you should know that it won't fly any differently.
Once I was over that bummer period of I just bought the old model. Then I realized, well, it doesn't actually make a difference yet.
Yeah, these things
are for a couple of days.
Yeah, and that is actually intrinsic in our business, which is to say that we're kind of at the cutting edge, or the bleeding edge, if you will, of robotics. And if what you want is stability and such, then you should buy a Faraday AR. One should buy a Faraday AR drone and have fun for now and wait till things stabilize. But there are people who really do see this as a kind of a frontier and an experimental platform, and so they're very demanding about wanting the latest sensors and computing platforms, etc. So we're going to be releasing. When is this podcast coming out?
Should come out like today.
Oh, okay. Well, then I can't talk about what we're going to be releasing because it'll be coming out mid next week. But we're going to be releasing a series a series of new boards.
Hold off on all your sales there, folks, because they're about to release it. It's the what is it? They call that the
release party?
Osborne effect.
The Osborne effect.
Yes.
Yeah.
Because Osborne went under because they announced a new product and didn't deliver, and nobody bought their old one.
Well, I can't say that we're going to be releasing an APM 2.5 board next week, but that's actually, again, functionally identical. It's just designed to be easier and more reliable, easier to make and more reliable. So that shouldn't stop people. But there will be a brand spanking new board, which is actually designed for a different market segment, for really kind of advanced, academic use. I don't know whether you saw that University of Penn Swarm Lab, the swarming quads. Yep. So if you ever want to do that yourself, now you can. So you should see an announcement this week on that.
I'm hearing Zigbee this week. I think that's my prediction. Zigbee talking amongst them and stuff, right?
So you probably know that we have released our a competitor to Zigbee with the 3DR radios, which are a competitor to the XB radio. So the 3DR radios use the Hope RF chip. So we love XBs, but they're closed source, and that cannot stand. And
nothing will get in their way.
And they're also a bit of a hassle to set up, and they brick. And we just said, enough of that. So we've released our own radios called 3DR radios that in 900 and 433 megahertz that are do all the same thing, but they're half the price and longer range, and they never brick, and they're 100% open source.
What is the chipset on those? This is the same.
It's the Hope RF. It's the Hope RF chipset.
Hope RF. I've never heard of that. I'll have to look that up. Okay. That's cool. So that's actually the manufacturer, though, is Hope RF?
Yeah, it's basically the Hope RF RF chipset, and then we just built the kind of logic circuitry and the firmware, and more importantly, all the configurations, utilities, and such around it. So they're optimized for long range use right now. So if you want like a mile, that's the way to go.
Mm-hmm. Very nice.
Is that legal? How are the legal requirements handled, or have Hope already done all the legwork?
I don't know, frankly, and it depends on the country. We sell to developers by and large, so we don't deal with FCC clearance ourselves.
Oh, yeah.
So you just leave it up to the user. It's if they want to use it commercially, that's their
exactly
business. Yep.
Yeah.
Chris, I had a question about the manufacturing side. when did this all went down? Mid 2000s, right? That's when this all started. Was it later than that?
The manufacturing side?
Yeah.
Oh, no, 3D robotics is only 3 years old.
Oh, 3 years old. Okay.
Yeah, I mean, DIY drones started in 2007.
Okay.
That DIY drones, just to be clear, is the community. It's just a free community, and that's where people post blogs and talk about this stuff, and that's where everyone hangs out. But 3D robotics is the company.
Okay, so I was confounding the two. So I don't think Kickstarter was in the mix at that point, but if you had to do it all over again today, would you have done a Kickstarter to actually get this up and running, or what's your take on that whole thing?
That is a great question. I love Kickstarter, and Kickstarter does 3 things really well, 2 of which we probably would have used anyway. But the 3 things it does well is it basically moves money forward in time.
Yeah.
It moves money from the when you sell period to when you need it period, which is when you're designing the product and buying parts, etc. So that's really the problem with making stuff, is that you don't get paid until it's all done, and you need the money at the beginning of the process. Right. So by taking pre-orders, it just moves money forward in time to when it's needed. The second thing it does is it does market research as to whether people really want the product, and that's super, super important. And the third thing it does is it creates a community that's basically invested in the product and will market and sort of evangelize for it and be your boosters and supporters and reality check and all that. And I think all products basically should have communities going forward. So of those 3, we already had 2 of them. We weren't money constrained. We had plenty of money, so that wasn't an issue for us. And we already had a community in DIY drones, so that wasn't an issue either. The market research, probably would have been good. I think there's other ways to skin that cat. Just just kind of sharing designs with the community and getting feedback is a good way. So I think that wasn't super crucial for us. So I think in our case, because we already had a community and money was not a constraint, Kickstarter would not have been the best process for us, because there's such a level of commitment. You're basically promising to create a product.
Oh yeah.
And people are sort of feel like they're buying that product. And if you change gears a lot in the process, as inevitably happens in development, there's a slight worry that you've kind of bait and switched them. And I kind of reserve the right to change gears.
That's right.
Because I usually don't get it right the first time. So that's the one reason why we probably would not have used Kickstarter. But others who didn't have their own community or didn't have enough money up front, I think is a great option.
That's always the problem when you've taken somebody's money. You've promised something. That is another pit of despair.
Yeah.
In itself, or it can be.
Anyway. You take $1 of money and you basically, people feel like you owe them their life, your life.
Yes,
it's just they're incredibly demanding.
So no app development in your future then? I mean,
well, we do take people's money for hardware.
That's true.
One of the real complexities in our world is that we sell hardware, but this is just commodity hardware. They're basically Arduino boards with commodity sensors. But the software is created by a community of volunteers and given away for free. And the hardware usually works fine, but people have find bugs or performance issues or the documentation or whatever with the software, and they're like, why don't you do a better job of supporting this? And we're like, well, we actually didn't sort of create the software. It's free. It's kind of created by the internet, and you didn't pay them, right? You got that for free, and people just don't understand the distinction.
You don't think it's getting any better? I mean,
I think that at the end of the day, the hardware side does have, I think, maybe not a responsibility, but they're well advised to be able to do some kind of software support. But I mean, look at the examples with Linux. Red Hat. So Linux is basically given without warranty, right, and maybe without enough documentation. That was a market opportunity for companies like Red Hat and IBM to provide third-party services for those who want sort of full end-to-end support. And I kind of feel like the same thing's going to happen with open source. The open source hardware movement is that, let's say you get MakerBot actually does quite a good job of handling both of it. But let's imagine that MakerBot sold you the gear and then it was like, hey, and you're on your own with the software, and you're like, well, either I'm like really competent with Python and I can handle that, or I'm willing to pay extra for someone who's going to give me kind of full on service.
Yeah. Do you want the extended warranty, right?
Exactly. So that would be an opportunity for people to sort of sell kind of value added MakerBots.
Yeah.
And I think you're already seeing people with the with the UAVs, packaging them up and selling them in, system integrated in planes, with service, attached. Right. And we think that's great. And the more the merrier.
That's awesome. So how does it play off against? I mean, I wrote on the Discuss forum where people were asking questions, not to ask about the book, but I have to ask because you kind of said it there. How do you play that off where your book kind of says, well, you should give stuff away for free, and then you say, well, giving stuff away for free kind of sucks?
Well, the book in fairness says that is all about freemium, which is basically you should give things away to drive sales.
Right.
So our model's right out of the book. As a matter of fact, it's even covered in the book. We give away the software, we give away the bits, and we sell the atoms.
Yes, I've heard that before many times. That's
we
Neil
give away the software.
Well?
Gershenfeld has the atoms and bit construction. I'm not sure he does the economic side of it as well.
Okay.
But yeah, so the software is free. Hardware is paid for obvious reasons, that the marginal cost of distributing software is zero and the marginal cost of distributing hardware is not zero.
Correct.
And so that divide is I mean, a lot of people sort of read the title of the book, which is free, but didn't actually read the book itself, which is all about getting paid. And so they're like, I can't believe you charge for this book. And you're like, maybe you should look up freemium. It's about finding a way to build, to use free as a marketing tool to give people something of value while getting a fraction of them to upgrade to a paid version, which is more value.
Full disclosure, I have read the book. It was a couple months ago, so that's why.
Okay, right. It should have been more memorable. That's my fault.
So speaking of the forum, we should get to some of their questions real quick. There was a lot of questions about the actual, the UAV side of things, and a lot of the news items about, robotics in the sky kind of coming under scrutiny now, and the FAA and all that other stuff. Kind of what's the deal with that, and where do you see that going?
Sure. I mean, let me give you a quick overview of where it's at. So I'll give you the U.S. rules. They're somewhat similar to the European rules. Australian rules are actually a little bit more liberal, but I'll just give you the U.S. rules. Right now, there's the FAA controls the national airspace, and right now UAVs can fly under basically model airplane restrictions, which is under 400 feet. So manned aircraft are like their floor is 1,000 feet. There's a 600-foot buffer, and then there's a 400-foot where like kites and balloons and model airplanes can go. So under 400 feet, you have to stay within visual line of sight, and that's to achieve what's called sense and avoid. So that means that the number one rule about the airspace is that you got to be able to see other aircraft to avoid collisions. Now, if you don't have a person in the cockpit, then you don't have a good way to see. Even if you have a video camera in the cockpit, you don't have the same peripheral vision. So you don't have that same sense and avoid ability. So you need someone on the ground to be able to see the aircraft in the sky and see the sky around the aircraft to avoid any other aircraft. So that's the visual line of sight rule. Then you need to stay away from built-up areas, for populations, away from airports and things like that.
Oh yeah.
So that's the way we fly. Now that's only for non-commercial use. For commercial use, you have to get this crazy, you have to go through this paperwork process to get what's called a certificate of authorization, a COA, and that's really hard, practically impossible for most people. So what's really interesting is that my 9-year-old can fly drones on the weekend in the park and often does, but Lockheed Martin can't. Or the University of California, or the University of California, Berkeley, around next door to us is not allowed to fly, but my children are, and that's all because we're amateurs and they're commercial. Now, and in 2015, the FAA is supposed to be releasing a set of rules that sort of creates some categories by which small and relatively not dangerous UAVs could be allowed to fly commercially with a kind of a minimum regulatory burden. And we'll see what they define as small. We'll see what they define as minimum regulatory burden. We'll see what the rules are. But that should allow commercial use of UAVs. Right now, people are doing it, but kind of under the radar and kind of out of harm's way. But going around 2015, it'll probably be delayed, but around that time period, there should be a way for them to do it legally and safely. And we're really hardcore about adherence to this because it's just common sense. This is just safe. And one of the nice things about UAVs as opposed to radio controlled airplanes is that we can actually enforce this. You can create you can tell the thing that if it gets beyond a certain distance away from you,
Yeah,
it flies home. And so flyaways are a problem with radio control airplanes, but with UAVs, you just click a button and it returns to launch.
But how does that autonomous aspect come into it? Because you're no longer in control, or you may not have line of sight. Should it be allowed to fly home, or should it just immediately land where it is? Regardless, I mean, that's all.
So we don't hard code that, but basically, all of our drones have the ability of manual override, which is that if anything goes wrong, you always can and should take over manual control. We can't stop you from flying out of visual line of sight, but we can make it very easy to do it accidentally, just to not do it accidentally rather. So for example, we have a geofencing feature by which you just describe a 3D box in the air, and it won't leave that box. By the way, it's a great training feature for kids or people learning how to fly. You can't crash. You can dive it straight to the ground, and when it hits the bottom of the blocks, it'll take control away from you, fly back to the middle of the box, and then return control over to you.
That's
Fantastic.
Awesome. Yeah, I actually have very limited experience with UAVs. Most of mine comes secondhand from Dave talking about his, so haven't taken that leap yet, but that sounds like a good way.
Everyone's really into multicopters, quadcopters, hexacopters, etc. And we've got a lot of them, and that's most of our communities into that as well. But we actually recommend people start with planes. The real foam planes, they cost like $60. The nice thing about the planes is that when things go catastrophically wrong, as they sometimes do, they don't fall out of the sky. They kind of glide.
Rock mode.
When they do fall out of the sky, they kind of bounce, and if they hit you in the head, it doesn't hurt, and they're really kind of, they're kind of fun and lovely and just a relaxing experience. Whereas multicopters are just inherently unstable and inherently unaerodynamic, and catastrophic failures are expensive with copters and pretty cheap with planes.
Well, you know what they say about helicopters? They actually beat the air into submission.
Yes.
That's how they fly. Right,
and a hexacopter does it 6 times.
They shouldn't have any right to fly.
I know,
yeah, exactly.
I know, and it's just, it drove me crazy watching the Avengers. When they had the aircraft carrier quadcopter, and one motor goes out and it just stays horizontal.
Yeah, I know.
It's like,
yeah.
that's not what happens. It's going to be flipping crazily to the ground.
Yeah. Oh man, that's funny.
What other questions have we got on here? I think there were a lot related to the electronics manufacturing side of things as well. But
Tony Robb wrote in about he asked, what do you think is missing from homebrew UAVs, and what would you like to see in RG Pilot 3? And he said, what silicon hardware do you think is missing?
Oh,
from
yeah.
homebrew?
So I mean, we're all upgrading to the ARM core right now, and we've stuck with the Arduino platform. We're big fans of the Arduino platform, not because it's about feeds and speeds, not because it's the fastest or most powerful processing board. It's not, but because it's got the lowest barrier to entry. It's got the best community, the easiest to use development tools, and we believe really strongly in sort of inclusiveness and accessibility. And we thought that was more important than clock speed and all that. And the truth is, we have a really good performing autopilot out there on basically an 8-bit processor. So everyone who said it was about feeds and speeds it turns out it's more about algorithms. And the best way to get good algorithms is with a big community. And the best way to get a big community is to have a very accessible, easy to use development tool chain. So we're big believers in Arduino. Arduino is moving to the ARM processor later this year. They've already released. Released a development board called the Due, which is built on the Atmel SAM3X. I think it's a Cortex M3 core, but so we're going to be upgrading with them. So we'll be on ARM by Q4. In the meantime, there are other platforms, including one that we may be talking about later this week, that are
right.
built on the STM32. Anyway, the 168 168 megahertz ARM core, which is I think the M4, if I'm not mistaken. I get really confused with ARM nomenclature, but
the M and the A and everything,
At any rate, we all have, we'll be on ARM, across the board by the end of the year. Now, the question is, what are we going to do with that? What do we need the power for? And the answer is It's not immediately obvious. Right now we haven't even maxed out the existing Arduino boards. We're running at about 60-70% of capacity. We have the chipset, the sensor chipset we use, the InvenSense MPU 6000, has a built-in processor right in the chip, which does sensor fusion. It's called digital motion processor, and we're going to be turning that on in the next couple weeks. That'll free up a lot of processing power from the main board as well, if you want to use that. So we still have a lot of kind of overhead in the existing chips, but as you go forward, when you think about what you might do with like infinite processing or close to it on these new chipsets, the first is you run all your algorithms faster. So you're doing it, rather than doing our sensor fusion at 100 hertz or 200 hertz, maybe do it 400 hertz. That's good. The second is you run a real-time operating system. So a lot of that kind of preemptive, all of that time scheduling stuff and the preemptive stuff gets easier, and you don't worry about collisions and adding a feature that ends up slowing down or messing up other features, and that's good. It should ease development. A third thing, and this is probably the most important, is learning. Right now, one of the biggest problems with UAVs is that you have to configure them and train them. All aircraft are different, and this, especially in open source ones where everyone can put together their own frame and different motors and props and and dimensions and all that. All that has really kind of profound implications on the aerodynamics, and you can have there's like dozens if not hundreds of gains and PID settings that you optimally would tune for this.
Yeah, tell me about it.
It's really hard, and if you don't buy the stock platform, some tuning is involved. That should be a learning thing. That should be machine learning. Basically, what should happen is that you should take off and fly it manually a little bit, and in the course of flying it manually, it should just figure out for itself what those gain settings are.
Of course, it should. Yeah. That's an obvious.
So that's gonna require a lot of AI. Basically, it's a lot of pretty hardcore statistics and no small amount of memory as well to record all that data and process it in real time. It could be done on the ground actually, and we have a relatively fast telemetry link that does do a lot of some kind of AI, including scripting on the ground. So you could do it on the ground right now, but ideally it would be a black boxed thing in the air. So that I think learning is kind of the frontier of robotics in general, and that's probably true for aerial robotics as well.
That sounds really impressive and really hard, actually, like you said. And any thought towards moving towards parallel processing? I mean, you said RTOS, which is quasi-parallel because you do scheduling either round robin or whatever else the RTOS is. But ever any thoughts of FPGAs, or is that too far out?
It's interesting. I mean, we only hear about FPGAs from like newly minted engineers. It turns out that what's going on because of smartphones, what's going on with just the standard ARM cores, is the Moore's law is so fast. I mean, it's accelerating so quickly. There's just so much power coming out from these kind of standard platforms that we don't really see the need for custom hardware. It's just the kind of commodity hardware is just getting so good so fast, and I think that's taken a lot of the motivate, a lot of kind of the appeal of FPGAs away, that you can just kind of throw silicon at it, commodity silicon, and things get done. So we do parallel processing already, as on the existing Arduino board. We the APM2, we have 3 processors running simultaneously. One handles the PWM, the RC input, and processes that. Another one's the main processor. Another one is the DMP processor on board the sensors, the gyro and accelerometer sensors, which can be doing some sensor fusion. So there's that kind of physical separation of processing, and then as the chips get more powerful, then you can just preemptively multitask with software and an RTOS as well. But there are people who use parallax propeller chips and have tried to do that. I mean, there are some autopilots out there. I don't know how many of them have kind of really effectively multitasked or parallel processed with that. I just don't know enough about the architecture. It hasn't really taken off. I think there's only 2 autopilots out there that use it. So for whatever reason, it hasn't been a kind of a gating factor in our business.
Yeah, I mean, I guess I didn't think I didn't know it was like 100 hertz kind of stuff too. So that is lower than I would have guessed. I don't know why I thought it would have been higher, but in terms of scan rates and everything.
Yeah, I mean, 100. So basically, when you just do the math, I mean, when an airplane, you can't move a control a surface faster than 50 hertz. The servos only go at 50 hertz, so there's no point in doing your computations any faster than that. For copters, you're basically changing the speed of a motor, and past about like 200 hertz, you're talking about less than you're changing the speed within a revolution. So you're multiple times within a revolution, and it's really questionable whether there's any kind of physical reality to that.
Yeah, that makes sense. Yeah.
Where do you see the autonomous aspect of these things going? In terms of, you talked about the increased processing power afforded by the high end ARM cores. Does that mean the community is going to get more, or the stock platforms are going to get more into 3D mapping, real-time mapping, and all that sort of stuff, so that they can actually map where they're going. They can actually map objects and avoid them, and on as they fly back autonomously, and all that sort of stuff.
Exactly. So right,
where's that heading?
So right now they're full. So we in robotics you talk about sort of the inner loop, which is kind of the basic stability. Yep. So if you're thinking about like the human equivalent, you're walking down the road. What keeps you upright? It's your inner ear, right? So your inner ear, your balance. System, yeah. So just kind of knowing where down is, we call that the inner loop. Then there's the outer loop, which is kind of, where am I going? Left or right, or just figuring out what direction to go, and that's kind of basic autonomy. That's following waypoints, automatic takeoff and landing, etc. Kind of you can dynamically change it, but it's basically just sort of following commands. Then there's the kind of the third loop, which you think of as sort of as the kind of what's my mission here? What am I really trying to do? And this is the loop of like I'm trying to go to the store, and I don't want to run into people, and I need to wait for the stoplight, and things like that. The kind of AI layer, and that's the layer. That's, I think, where autonomy is still going, is starting to get interesting. By the way, the military is really not there either. The amateurs are pretty much up there with the military in terms of autonomy. It's
I think they're way ahead.
When you think of like a Predator out there, or one of these military UAVs, there's like 60 people on that crew.
Really?
I mean, with an airplane, there's between the operators and the ground crew and the kind of the system analysts, or the mission analysts, and the CIA analysts, etc. I mean, there's just tons of people working on those crews. So there's almost like no fewer people than a manned aircraft. And they're often actually, not flying autonomous missions. They're doing the inner loop themselves, which is they're staying upright, but the outer loop as to where you're going is being actually point and clicked on a map. So the amateur stuff, the Arducopter and Arduplane and others like it, are basically fully autonomous in that respect, which is you give them a mission, automatic takeoff, follow waypoints. They will kind of, follow the topology, which is to say that, they know, with Google Maps, they know the elevations of the various waypoints, and you can maintain an elevation for that. Then it'll finish its mission. You can program it to look at a certain point of interest, keep the camera focused on it, loiter at certain areas, do various camera functions, and then land. So that's a fully autonomous mission. But what it isn't doing is noticing that there's a telephone line in the way, or the cloud came in, and now my camera can't see anything because you're over the clouds, or all that kind of stuff, and that kind of adaptive mission control, right? Is the next big step, and it's going to start with things like image processing, optical or LiDAR. As you probably heard, one of the big crises right now in the UAV world is GPS spoofing, or just loss of GPS blocking. And you take GPS away from Mars, and they're dead. I mean, they don't have any idea where they are. Now there's a couple ways to solve that. I mean, one is just dead reckoning, sort of saying, oh, I lost GPS, but still I kind of know which direction I'm going and where I came from, and I can kind of backtrack through just kind of inertial data, and make it more or less back until I can get GPS again. The second is actually looking for other wireless sources, and just sort of saying, well, here's some kind of known frequencies, known radio signals out there. I can tell through Doppler effects and others and signal strength whether they're getting weaker or stronger, what direction I'm going. So let me just sort of fly along the gradients of the existing RF space.
Nice.
And so that's really kind of interesting and very doable because there's RF everywhere. And the third is imaging of the ground beneath you with LiDAR or optical, and sort of saying, and having a database on board that that knows what the ground looks like, and sort of saying, oh, whoa, okay, well, I mean, what would you do if you were a pilot and you lost your radar, your compass, or your GPS? You'd look down to the ground and sort of say, do I recognize anything? And the great thing about drones is that they can have an infinite database of terrain characteristics. So between LiDAR and optical and other kind of multispectral imaging, they should be able to kind of look down and kind of find their way home.
Right.
So that's the next frontier.
Whew. That sounds exactly what I need for my canyon copter, my autonomous canyon navigating. Actually, my friend Roger, who's working on this with me, he'll probably kill me if I don't ask you. We're developing this canyon navigating quadcopter. Okay, it's a standard quadcopter based on the RG Pilot, but we want it to navigate autonomously through a camera and get one continuous video shot of the trip through. And we don't need it to do anything fancy. We need it to move slow, steady, avoid obstacles up and down, rocks and water and stuff like that. It's in a canyon. The walls are only 10, 20 meters wide at most. There's no GPS reception.
Yeah, that's hard.
We feel like no one else in the world seems to have done this, and we're probably biting off more.
Here's a couple of things. We do support sonar. Already.
Right. We've been thinking about that.
So we do support sonar right now.
How accurate is that? Because we're only like a couple of meters off the ground here. We're not going to be 300 feet up. We're going to be
sonar's
5 meters.
Oh yeah, sonar's actually ideally 15 meters with 15 and less.
That'd be our tops.
50, so sonar's good within a 15-meter range. So we absolutely support sonar. We actually use sonar already on APM-1, which had a kind of which it shouldn't have a great barometric pressure sensor. We actually use sonar for altitude hold. On APM-2, we've got to improve baro, so we don't need that. But so we support sonar. There's no reason why you can't have sonar in all 4 directions. If you go onto our site,
I was going to say that's what I was going to ask. What about the different directions? Because we basically want to center the thing within the walls of the canyon, so we need left and right.
Not a problem.
And then forward and down.
Not a problem. As a matter of fact, if you go onto our site, a guy, a member named Jose Julio, has a great shot of him playing tennis with a quadcopter.
Oh, nice. I've seen that. Yeah.
So basically, they just have it's a very slow motion tennis, but they basically swing at the quad, and the quad sort of moves away and moves in the direction of the other guy, and the other guy swings at the quad, etc. So if sonar's good enough for you, sonar's totally doable.
Right.
Optical gets harder.
Yeah,
we do have optical. We also support optical flow, and we actually sell an optical flow sensor. And the nice thing about optical flow is that you get these kind of vector fields that will give you a sense. They'll give you a sense of kind of objects. As objects get closer, their vector fields diverge.
Yes. But this is sounding promising.
Yeah, but it's probably more. I mean, to do it in 6 directions. Yep. It's probably more processing than you want to do. To which I would say, wait until later this week.
Oh, okay.
There we go. Dave's going to like this week.
Or are we better off doing like a waypoint base, actually going through and then programming the... Actually, ideally, right, we wouldn't even want to fly it manually. We want to just move it along because we can walk through the canyon. So hold it here and then, we can just manually hold it there and then program that as a waypoint. Yeah. So it would need...
So I think, so basically our waypoint, so GPS is good, I think with the 2.7 code that we're going to be releasing this week as well, you should be able to stay within about a sort of a 3-meter box. So,
that's not good enough for us.
Yeah, it needs to be, okay, because winds can, we try to stay in a 1-meter box, but winds, etc. Also, in a canyon, you might have GPS multipath problems.
Yeah. Oh, yeah.
So I wouldn't bet my life on standard GPS on that.
Yep, no.
You could fly manually, and just
Yeah, I know. We could, but then the canyon snakes, twists and turns, and we wouldn't be able to keep up with it because we have to abseil down waterfalls, and we've got to do all sorts of nasty things.
So what's the width of the canyon?
It can be anywhere from 2 meters wide to, say, 20 meters wide.
Yikes.
Very, very, very narrow.
20 meters would be good. 2 meters, I just would not. I think that's just too hard for GPS.
That's the thing. I mean, we ideally we want something. A quadcopter's overkill. They're designed, they're very maneuverable and things like that. We almost wanted to do like a blimp, like a remote control, helium blimp, nice and steady, stable, just goes forward and gently turns left and right, but you
the
can't
EV
lift a
Blog
payload
Zeppelin, huh?
that.
Yeah, we actually
Zeppelin.
did. We started with the blimps. Blimp Duino was our first one. Blimps are fantastic indoors. Outdoors, to be able to fight winds and and thermals and things like that.
We're effectively indoors. We're with a canyon. We're effectively indoors.
Really?
So
well,
pretty much. These are pretty enclosed canyons. They're almost cave-like at some
Our
points.
blimps were too small for a proper payload, but there's no reason why you couldn't do that with a proper blimp. Blimps are lovely. They're real fun to work with vectoring thrusters. You can get pretty good altitude control. You'd probably want a blimp of at least, I would say, 2 or 3 meters.
I know that's the problem. Therein lies the problem.
Sharp rocks,
we have
that's the real problem.
Haul all this gear down into the canyon.
Right. Yeah, and then there's sharp rocks and all that. Yeah, that's a tricky one. I mean, is there a stream or anything underneath it?
Yes, there's water. It has to be fully waterproof, so it lands in water,
so here's a
sand,
dumb question.
rocks,
I mean,
everything.
why not just have a raft that goes down the stream and just a balloon attached to the raft?
Well, you can't, unfortunately, because it's all rocky and there's waterfalls and there are all sorts of stuff.
Oh.
So unfortunately, I know it's difficult. It's that's why no one's ever done.
Well, there
this.
is one last thing. FPV.
Oh yeah.
FPV. Flying first-person view.
Oh yes, we were thinking about that. Yep.
Those are great videos too. If people aren't already subscribed, the DIY Drones feed is spectacular for that kind of stuff. Every day you basically get a new FPV kind of video from someone, and it's just
which is if you don't know, FPV is first person view.
Yeah, flying
so
with
there's
video.
A camera mounted on the front which transmits
exactly.
Video
You're flying with video. You're flying as if you were in the cockpit. You're wearing video goggles and you have a real time video feed.
That's probably our only way to do it in the end.
Yeah,
I think.
it takes a little getting used to.
But then when the canyon moves around, but when the canyon goes around a corner, our RF's just going to drop out. I'm sure we haven't actually trialed it yet.
Well, maybe. I mean, here's the thing: FPV comes in 3 frequencies: 1.3, 2.4, and 5.2 gigahertz. And depending on as different frequencies bounce in different ways around corners. You can also, depending whether you want to kind of bend the rules a little bit, you can go all the way up to a watt of out.
Oh wow!
Yes. Well, this is in the middle of nowhere. This is like in the middle of the wilderness. So we can.
Yeah, so I think you throw enough juice at it, pick the right frequency. You might be good.
Yeah.
Before you do it,
go through the rock.
If you know somebody with one of those Parrot AR drones, do try to fly that in FPV mode and see whether you can do it. Because for the life of me, I can't do it.
I think that's what we have to do. I think we have to get one of those cheap Parrot drones and go down there with our iPhone and try and.
Yeah, the nice thing about going with the Parrot AR drone is that if you do hit the wall, it's not a disaster. They've got these nice foam ring on the outside. Yeah. If you crash, it probably won't break.
Well, we have to make it waterproof. That's the only thing. Is it able to lift the payload? Can it hold a decent payload?
It's got a pretty decent camera. The AR drone 2 has a high def camera.
Yeah, 720p built in. Yep.
Although that's the forward-looking camera, not the downward one.
Chris, is one last question from besides Dave's troubleshooting, hounding you for troubleshooting. I wanted to hear a little bit about your book before we go, because you've got a new book coming out in October, and we wanted to talk about that real quick. And it kind of fits in.
So the name of the book is Makers, the New Industrial Revolution, and it's really about, what I think is sort of, the future of Western economies, which is taking the web's innovation model, which is all about, digital stuff and open source and community, et cetera, and applying it to making real stuff. And it's basically that, 30 years ago, we introduced the word desktop to computing, with, the Apple and the laser printer and all that kind of stuff, and it just kind of changed the world. And we now have the word desktop manufacturing. We talked about 3D printers at the start, but there's other digital fabricating tools, CNC machines, laser cutters, and so on. And these things are now right about at the point where regular people can use them. They've become democratized, and what's great about it is that because they're digital, and because these ideas all start digitally, they can be shared. And suddenly everything we learned about doing stuff together and, about the advantage of innovation models, in the last 20 years of doing the web, we can apply to, manufacturing and making real stuff. And suddenly it's not about who's got the cheapest labor. It's about who's got the best ideas. And
exactly.
Yeah. And so that I think is, I live in the United States. And so obviously, the future of the American economy is important to me. And, real countries make stuff. And we still make stuff, but there was a sense that was a losing game. And I think that the day when the cheapest labor wins is gone, and now the best ideas win, thanks to these digital tools, bringing manufacturing back to everybody.
As an Ohioan, yes, we have lots of we used to have a lot more, but manufacturing is a very strong focus around here. And
exactly. And it will be again, I think. Those skills, I hope they're not lost because, those skills are going to be very much in demand.
They're never lost. They're always lurking.
Yeah.
They're always lurking.
And I can tell you, as somebody who originally did manufacturing in China and then brought it back to the United States myself, what you might lose in in a little bit of margin, you gain in flexibility and quality control and all that. And, once you start to see these kind of, more high value, high innovation manufacturing, you realize that, you add a little automation, you add a better innovation model, you start to see a kind of a domestic supply chain building as we're starting now seeing electronics, and suddenly making stuff in the United States makes sense again. And it worked for us. And I think what we're seeing with the maker movement, which is what this is called, is really just the kind of, the homebrew computing club, start of what is ultimately going to be, the computer industry. So I think we're on the verge of something that's, the web was big, but manufacturing's bigger. And to see, in the same way the web transformed like media and, content and information, I think, the same forces are about to transform, manufacturing, which is, something like 70% of the world's economy.
How do you see the interplay between like the really big companies and the desktop manufacturing side of things? Because we always hear the things about desktop manufacturing. We've seen it ourselves in terms of 3D printing, and like you said. But I mean, what about the large manufacturers and stuff like that? And how do you see that all fitting in?
It actually takes me back to my first book, The Long Tail, and everyone said, is this the end of the blockbuster, the end of the mass market, the kind of, the Hollywood model of content. And I was like, no, it's the end of the monopoly of the blockbuster. I mean, I think, right now big manufacturers basically own it, because of their, economies of scale. And, if you're not operating at Walmart scale, you can't compete. And I think what that means is that a lot of products designed for kind of more niche audiences just don't get made because big manufacturers don't want to operate at that scale, and because retailers, which are the usual process of selling these things, don't want to operate at that scale either. And between the ability to do more kind of small batch manufacturing efficiently, which is what automation allows you to do, and the internet as a kind of a growing retail distribution channel for products, means that suddenly you can have a long tail of things as well.
Awesome.
So in the same way that mainstream media wasn't killed by the internet, but it was just the internet just created a huge amount of competition, and so you still have Hollywood, but you also have YouTube. I think you're going to start to you're still going to have mass manufacturers making toys or commodity electronics,
Nexus 7s or something like that.
Exactly, but you're going to have that that long tail of stuff that's designed for smaller audiences and maybe fits them better.
That's great.
Speaking of YouTube, I, of course, make my full-time living from making YouTube videos. And I wanted to ask about Wired magazine. Go a bit off topic. UAVs all show. Wired, where do you see the print media going? Because Wired is a print magazine. It started out as a print magazine, did it, or was it always digital?
No, it started as a print magazine.
Is it just print? And how has that moved? How is digital in comparison to print the print edition now, and where do you see the video side of things going?
So we started in 2003 as a print magazine. So we're hitting our 20th anniversary, unbelievably. I joined about 11 years ago.
How did you join, by the way? If I forget to ask later. How did you get involved in this?
I mean, my background's really kind of funky. I'm a kind of a high school fail out, a college fail out, played in like punk rock bands for most of my 20s.
Nice.
And then sort of late in life decided to get serious about school and went to study computational physics. Just in time,
I
thought after having failed for so long, I had to prove that I could do hard stuff. So I found the hardest thing I could do. And I was kind of okay at it. But then kind of physics went all pear-shaped because the accelerators got too expensive. So I ended up I had to find something else to do, and I kind of decided that the next kind of adjacent space was the science journals, if not science itself.
Right.
So I went to work for Nature and Science, and then I got recruited by The Economist because they tended to hire people from the science world to run the science section. And this was in 93. This was must have been 90. I guess 94 or so. And I said, rather than do science, there's this new magazine now called Wired that says that like the internet's going to be really big. And so I think I'd like to cover the internet. And they're like, okay, what do you need? And I said, I'll need a computer and an internet connection. So they got their first computer, and they called we were in London. They called British Telecom and said, this guy wants an internet connection. I think they dropped a T1 right into the back of the PC. And my bandwidth has gone down every year since then.
Yeah, doubled in price too.
Yeah, exactly.
There's a book in there, Chris.
So what I ended up, I was at The Economist, and I was based in London and then Hong Kong, and then I was running a New York bureau when Condé Nast, a big sort of magazine publisher that has titles like Vanity Fair, New Yorker, and Vogue, and things like that. Kind of
and Reddit.
A lot of fashion titles, yeah, and Reddit. I had bought Wired a little bit earlier, and wasn't it was kind of a hedge and a kind of a laboratory for the future, and they asked me if I'd want to take over, and I'd like Wired changed my life. They turned me onto the internet, so I was like, absolutely. So there's a very long and convoluted path that took me from punk rock bands to Wired, and yet every step makes sense,
great.
And yet the whole path is completely nonsensical.
Yeah, and further on to hardware and RG copters and everything else.
This is back to my roots. I mean, open source hardware is really just the kind of same boards we were building for physics laboratories. It's just more mainstream adoption. Anyway, so the simple answer on the magazine is that the magazine that started as a print magazine, it then very quickly started a website, and was actually one of the first. It did the first, arguably the first blogs. I don't remember.
Wow.
Remember suck.com and all that. The first banner ad was on Wired. Some of the first content management systems.
Wow.
We developed Apache. The server operating system. So that was really early days. Then that all kind of went along till about 2.5 years ago, when it became clear that tablets were going to be interesting, and so we were one of the first to have a tablet edition on the iPad. And I believe today we are tied with the New Yorker as the most popular iPad magazine, or tablet magazine. Actually, we're on all platforms.
It's a gorgeous version too. It's very nice.
Just came out on all the Android tablets via Google Play. So the simple answer is that I think the future of print can be sort of foreshadowed by the future of books. Which is to say that today you have a choice between a print book and a digital book. Earlier you said you wanted the Kindle edition, and me too. I prefer the digital books, and yet lots of people still prefer the physical books, even though they have that choice. And sometimes they prefer it because they just like the touch and feel of the thing. Sometimes they want to put it on their shelf. Sometimes they want to give it as a gift. You'll notice the production values of physical books are a lot better. I mean, the covers are embossed and die cut and fancy inks, and on a Kindle you'll be lucky to get get a cover at all, actually. So for people who value those kind of aesthetic qualities, the print book still has additional value. And I think the same is going to be true for magazines, that, increasingly people have a choice between the digital magazine and the physical magazine. And the digital magazine obviously is instantaneous delivery, and you can get it wherever you are, and you have your whole library with you, and it's interactive and multimedia and all that kind of stuff. And so the question is, okay, well, so as people have a choice between them, how rather than have the print one be a one size fits all, where we have to use relatively poor paper stock, because we print 1 million of them every month,
Wow.
so we have to use just for economics, we have to use relatively affordable paper stock and inks. What if we, and I'm like thinking forward like 3 or 5 years from now, what if we decide, okay, so here's the choice. You get the digital edition, which is relatively inexpensive, reflecting digital economics. And this is print edition, which we're going to make absolutely beautiful, the best paper stock, the best, ink and sort of foils and die cuts, etc.
There's no expense.
And you can get a glimpse of it already if you look at our Italian edition or our British editions, which print much smaller volume, like, 50 or 70,000 copies.
Right.
They're stunning. They feel like this like Fabergé egg. The covers are textured, and they don't use silver ink. They use like foil, and they're absolutely gorgeous. And they're a glimpse, I think, of that maybe the simple answer is this: that as people choose between digital and print, and more people and people increasingly choose choose the digital edition, then print becomes a smaller fraction of the total. Then maybe the print edition can get better. So as print gets smaller, print gets better.
Yep.
And maybe people will pay more for it because.
I was going to say it'll get higher margin.
Exactly, and it becomes an artifact. It becomes a really a kind of an object of desire, and kind of retains some of its physical properties that are so unique to a
and it retains physical value.
Exactly, the kind of thing you're really proud to have on your coffee table.
The way that LPs have made the resurgence as well, in the same manner.
Exactly. So, as go books, so may go magazines.
That's
interesting. And where do you see video fitting into all this?
Dave's
content?
asking for a job, Chris. I think that's an undertone here. I'm not sure.
I've seen his videos. I
trail.
love his videos. I think I've even tweeted his videos.
Awesome.
So video is a big part of what we do. We have a big video production team. I mean, increasingly we look a
team.
Yeah, we increasingly look like a Hollywood production house. I mean, we not only have a video team, we have a post production team, we have an effects team. We have people doing kind of
rub it in.
We're a pretty big operation. And the reason we do all this is because we integrate video into the digital magazines, on the iPad.
Okay.
And there's a sort of an obligation to bring video up to magazine standards. Now, the good news is that people want this, and they now have this. The bad news is that that's not really our skill set. We do our best, but increasingly we're starting to think about what is a magazine really?
It's a real question.
It can't be defined as the medium anymore. Is it a package of content? Is it long form, short form? Is it design? As the images are increasingly kind of Harry Potter like, in that they move. What are the skills you're looking for in the next generation of editors? I mean, are you going to hire people out of the video game industry? These are all interactivity is a big part of what we do. So these are kind of big questions for the future of the business, and ultimately they'll be answered over a matter of years, not overnight. I mean, we're still really at the kind of the early days of digital magazines, and we've been successful. Not everybody has been successful in digital magazines, in part because we're figuring out the medium, in part because people are just figuring out the way they get, how to get these magazines easily, and how to make it as seamless as music or books or film is on these devices. So I think that I think it's a work in progress, but this is definitely the future. Tablets have won. People love consuming their content on tablets. Magazines seem.
I haven't got one.
You haven't got one.
Haven't got one.
You got a Kindle,
I'm a bit of a Luddite.
You've got a Kindle, Dave.
I've got it. I love my Kindle. Yeah, because it's the right tool for the job. I love the right tool for the job. I hate the universal tool, that sort of.
I'm a pretty big fan of tablets of all sorts. Try the Nexus 7.
I will have to get one. Yeah, I'll have to try it.
Yeah.
I think I'll be a fan of China, but I will not read books on it, right? It's ridiculous. I just don't want to read a book on it. I want to read a book on the Kindle. The e-ink display is just kills me.
Really? I see. I guess I.
Nah, battery life I just don't want to have to worry about the battery.
Chris, don't take Dave as Dave is a bit of a crank as well. He's a gray beard in training. As soon as he learns how to grow a beard on his baby face, he will be. The first one will be gray.
Nah, right.
Dave, let me ask you a question. What screen is next to your bed on your bedside table?
What screen? A Kindle.
You've got a Kindle. So so let's say you want to check your email or the web or something like that.
I don't do it there. I sit in front of a computer bloody 16 hours a day. I can already do that all day, every day. When I go to bed, I just, I occasionally just want to read a book, and I don't want to have to worry about charging the damn thing.
Fair enough. And so you don't watch movies in bed or anything?
Oh, no.
All right.
Dave's got a pretty tight chain around his
So
house.
that's called bed hygiene. He's got good bed hygiene.
Yeah, that's good. Yeah.
Actually, seriously, for people who have trouble sleeping, it's very important not to have screens be the last thing you experience before you go to bed.
The light sensitivity on your cones actually stimulates part of your brain, right?
To say nothing of that kind of slight association with work and like things to do.
Oh yeah.
I love my Kindle, and so does my wife. She loves the Kindle. We've both got Kindles, and we love it.
Okay, well, the Kindle app on the iPad is excellent. I'll just say that.
There we go.
Right.
Well, Chris, we've taken more than enough of your time.
Yeah, we have. An hour and a half.
It has been an awesome conversation talking with you.
I agree.
It's very fun. I'm big fans of what you do.
Where can people find all your work? Maybe a quick rundown of sites.
Sure. So start with DIYdrones.com. That's the community. It's got something like 30,000 members, and it's very active. There's something for everybody there. My own personal stuff. I mean, you can follow me on Twitter at Chris A with the I being
I is
one.
A 1. Yeah.
Anyway, I presume you have show notes and all that. That's pretty much it. You'll find 3D Robotics. It's just the DIY drone store.
Yeah.
We'll
link in books and Wired and everything else. Correct?
Yeah, I'm kind of easy to Google, so
yeah, that's right. Just Google it. Yep, that's good.
Yeah, it's all out there.
I couldn't find a wiki page for you.
You can't find a Wikipedia page for me? Oh, no. It's there. It's full
there,
of
yeah.
It's full of all my crimes and misdemeanors, I'm afraid.
There we go.
Oh,
yeah.
I couldn't find it.
It's a very common name.
You weren't listed under the Chris Anderson.
It's under
Really?
writer.
Or maybe I got the spelling wrong.
They've got me under writer, yeah.
Oh.
Yeah.
Oh, right. Okay.
I know. Yeah, I'm not allowed to edit my
Yeah.
own entries, so it's
Oh, that
I know, I'm an
sucks,
editor,
yeah.
and I can't edit my own.
It's the ultimate
Well,
in
at least you've got
self-restraint.
one. We don't have one.
Yeah.
We're always thinking, we've made it if somebody's made a Wikipedia entry for us.
Well, you guys could do me a huge
that's
favor.
when we've
You're
made
allowed to edit my entry. You could go into that. You could go into the Chris Anderson disambiguation page and just write writer/editor.
There we go.
Slash entrepreneur.
We will add this episode in.
Yeah, we will.
To your wiki page.
Thank you.
Well, I think it's people want to know. They want to know the man behind the.
Good.
The everything. The man behind the everything. You seem to do a lot of stuff.
Absolutely.
So.
All right.
Well, thank you again, Chris. We really do appreciate it, you being on the show.
We do.
Good fun. Anytime.
It's been awesome.
Thanks.
We'll talk to you soon.
Talk to you. Bye-bye.